This will be delivered by Professor Owens, Executive Director of Cornell Lab of Ornithology. I would like to share a quote written by Victor Hugo, which goes like this: "Be as a bird perched on a frail branch that she feels bending beneath her. Still, she sings away all the same, knowing she has wings." I'm sure you would all agree that birds are some of the most elegant and inspiring creatures on the earth. They are symbols of beauty, joy, courage, intelligence, and freedom with their incredible ability to fly. Today is an occasion that would ignite your passion for birds and nature while fostering a deep appreciation for conservation efforts. I would like to extend my warm welcome to the members of eBird and the National Center for Biological Sciences for conducting this event, along with Department of Zoology, St. Joseph's University. We would also like to extend our gratitude in making us a part of this wonderful session.
As you know, eBird has had a long tradition of integrating science and citizens. Events such as Campus Bird Count, Young Birder Event, and Great Backyard Bird Count provide a wonderful forum for both the general public and aspiring ornithologists to participate and contribute to scientific research. Today, we have the great opportunity to welcome Professor Ian Owens, the Executive Director of the Cornell Lab of Ornithology at Cornell University, who will be speaking about big data, citizen science, and conservation. We are delighted to welcome you, sir. And would like to express our gratitude by presenting a small token of appreciation. I invite our registrar, Dr. Melvin Colasso, to present the memento. Thank you, sir. I now humbly welcome National Center for Biological Sciences, Bird Count India. Moreover, we'll thank Dr. Suhail Kader and Praveen J. For constantly coordinating with SJU in order to make this event a success. I welcome respected professors and students of St. Joseph University. Last but not the least, I welcome all the eager members of the audience for their active participation. Hope you all enjoyed the session.
I now invite Dr. Suhail Kader to introduce our speaker.
Thank you so much. And thank you to the Natural Science Association and Zoologia, and of course St. Joseph's University for hosting us over here. My name is Suhail. I'm speaking to you on behalf of BirdCon India, as well as Nature Conservation Foundation and the National Center for Biological Sciences. And together with everybody else, welcome you to this occasion. The speaker today, Professor Ian Owens, spent 20 years of his first half of his career in academia in the UK and in Australia. He's an evolutionary ecologist, a behavioral ecologist, and then he decided that he wanted to switch and do things that were more public-facing, to do with conservation. And so he worked at a couple of natural history museums to begin with, and now for the past 2.5 years, I believe, is the director of the Cornell Lab of Ornithology. And I should say something about the Cornell Lab, which is part of a division of Cornell University. It is a very interesting place. It's a mixture of an academic department, a technology organization, and a conservation organization. And because of this unique mixture, the lab has been able to do amazing things. It's about 100 years old. And in the last 30 years has been increasingly looking outward, more globally, working with lots of partners all across the world to bring the message of birds and through birds' nature and conservation to large audiences in North America but all across the world. And today Ian will be telling us something about this journey and about how the work they do and the work that we can all do together can be so inspiring for birds, for nature and for conservation. Thank you, Ian.
Thank you, Sahal. Thank you to Bird Count India and to NCBS, who have been hosting us this week as we've met with many partners in Bangalore, and to St. Joseph's this evening. It's really, we have felt an incredibly warm welcome since coming to India about 10 days ago. We've seen a lot of birds, which we've enjoyed a lot, but we have met some wonderful people, some of which we have worked with for over a decade, and old friends, if you like, that we meet for the first time. But I think we've made many new friends as well. So thank you to everybody who has welcomed us so heartily. It's really uplifted us to be here. Should we have the first slide? Great, thank you. Should we start with the next slide as well? I'd like to talk to you this evening, firstly about what I see as one of the big challenges in biodiversity and conservation science, but also one of the big opportunities that we have right now. The big challenge that I see us having is to start to plot what we often refer to as bending the curve. I see that quite a lot of the work that the Lab of Ornithology and other organizations around the world have done over the last few decades has been framing this issue of the collapse of biodiversity around the world. And that's what I really mean if we, on the slide that has the kind of the curve on it, that decelerating part of the curve. As you can see, biodiversity collapsing over the last few decades. The thing that I think is the big challenge for the future is not just to plot the decline of that curve in even more detail, but also to try to figure out what is it going to take to bend that curve. We'll have a wait for the curve to appear. Is it possible to put the next slide up there? There. So the red part of that curve, I think, is the part that we put a great deal of effort into over the last few decades. What I'm interested in now is figuring out, over the next decade or so, how can we bend that curve? So biodiversity starts to increase again. Doesn't just stabilize, but also increases. I don't think we have a lot of time to do that. If we let that curve go down for another couple of decades, it will get really, really difficult to bend that curve. There are various analyses out there of what it takes to bend that curve around, and usually it's a mixture of conserving or protecting those areas that we already have that are rich in wildlife, restoring the areas that were previously rich in wildlife, and then transforming how we all live and particularly how we harvest resources. So bending this curve in this way isn't something that can just be done by scientists or academics or something like that. It would take all of society to work together to do that. And of course it's extremely challenging because bending that curve isn't just led by individual profit or even business profit. It requires people to think about more than themselves and more than the financial bottom line. Can we have the next slide, please? There are some great opportunities, though, to tackle that challenge. And the one that I'm going to spend most of this evening talking about is the combination of these two things. How the advent of new technologies, particularly artificial intelligence-driven technologies, interface with large mass participation citizen science. Those two things that come together give us a unique opportunity to map where biodiversity is in the world, and figure out which management techniques work well and which don't work well. So they give us, probably for the first time potentially, information that we can actually act on to guide conservation efforts. Let's have a look at one of the best examples of when those two things come together: citizen science and technology. This map here looks a little bit like those maps that are taken from space, where you can see different human settlements around the world. If you look at it a little bit more closely, you can probably figure out that what you can see there aren't just cities around the world. This isn't, in fact, human habitation. This is a map of citizen scientists around the world. Each one of those dots is a record of somebody submitting a checklist, a list of birds from somewhere around the world into a central system so that anybody can analyze it. Can we have the next slide, please? That system has already been referred to this morning as eBird. eBird is a platform that allows citizen scientists around the world to upload data, play with that data, analyze it, and make it available to decision makers around the world. It's largely, just go back one sec. It's largely an app-based system now, so people use their phones to record the different birds, send that into a system, say how long they have been looking at those birds and so on. And when they do that, that's called a checklist, and that's what creates a dot on that list. You can see the scale of this citizen science enterprise. 20 years of observation shown on here, 1.5 million nearly people involved in doing this, and over 1.6 billion records submitted. If you go to the United Nations Central Repository of Information about Biodiversity, called GBIF, Global Biodiversity Information Facility, about half of the information that's held in that comes from citizen scientists around the world, which I think is really remarkable, that people around the world are now doing this. Could we have the next slide, please? I'm going to show you an animation that illustrates how quickly information comes in through this sort of system, how quickly citizen scientists around the world are uploading information and making use of it. In a moment, we'll play this animation and you'll see that pale patch in the middle of the global map there start to move to the left. That shows this is going to show 1 day's worth of citizen science coming in from around the world. You'll see it start over on the right-hand side there, in the west, as the sun goes up, and gradually you'll see little yellow dots appear. Each one of those yellow dots is a person out in the field somewhere or in a city somewhere saying, these are the birds that I've seen, recording it in this system and making it available to other people around the world. Hopefully you'll be impressed by what happens in just 1 day. Now I should warn you that it isn't an average day, as you can see by the nomenclature there on the left. It's one of the days when we try to encourage people to do this. But still, these are typically existing citizen scientists and bird watchers around the world submitting that data. Could you press the forward button, let the animation go? You see the yellow dots appearing there in New Zealand and Australia? And each one of those is somebody submitting one of these lists. In Europe and Africa, the Americas now, and you can gradually goes to be white dots after they've been in the system a little bit. So in just one 24-hour period, over 300,000 checklists submitted to this system. And you can imagine how that magnifies over time and across the different groups. Could we go to the next slide, please? The most important thing to remember about this system is that it's driven by countries and community groups around the world. It really is a bottom-up way of collecting and using biodiversity information. When I talk to people about this system across America and around the world, this is the example I always use. So it's really great to be in India to be able to talk about Bird Count India in India. Bird Count India is one of the biggest schemes around the world. It has mapped diversity across the Indian subcontinent 43,000 bird watchers involved, over 50 million observations, 2 million checklists, and so on. In total, mapping over 1,300 species. That's an enormous achievement. Nobody, I don't think, has ever managed to map diversity at that sort of scale. And I would say that the reason for that is typically we have tried to do these sorts of things in quite a top-down sort of manner, where this is a really bottom-up way of doing it, utilizing that combination of engaged citizen scientists who love birds, care about the environment, and are tech-savvy enough to be able to contribute these sorts of observations to a big system. Bird Count India is actually a group of organizations that bring this together under a common umbrella. Next slide, please. Not only are these observations collected and brought together in that way, collated in that way, they're also analysed to create a report to look at the state of India's birds. This is actually the second state of India's birds, and this goes through each of the species and figures out which ones are declining the most, which ones need protection, and so on. It can provide state-by-state information on which birds are most vulnerable and which need protection. Again, I keep emphasizing this fact that this is a bottom-up citizen science approach going to give advice at the national or the state level. An incredible achievement. The reason I use this example so often is this is one of the cases where this is done on the largest geographical scale, where there are really a lot of birds, a lot of biodiversity, and a lot of conservation challenges. Next slide, please. If you now look around the world, there aren't many groups doing it at the scale of Bird Count India, but this is an illustration of the groups around the world that are now organising to do this sort of thing. Hopefully when you look at this map, you can see both the strengths and the weaknesses of it. You can see that in some areas of the world, very rich sets of citizen scientists now working together and organisations coming together. You can also clearly see there are areas of the world where that is not yet the approach. And one of the things that we try and do is encourage groups to participate in these sorts of schemes. Next slide, please. So what's it possible to do with this data? I think a lot of us have pleasure collecting the data. We enjoy bird watching, we enjoy listing things and so on. But what do people do with this data once it exists? Well, eBird data, Bird Count India data is all open access. It's all freely available on the web. But I'm going to give you a few examples of what people have done with it over the years. One of the things that's most commonly done is people try and map out where birds occur. This is an example from one of the barbets that's quite common here in southern India. And you can see that the indigo coloured parts of this map show you where this species occurs. You can also probably see, for those of you that are used to looking at field guides and so on, you can see the detail that's on this map. Normally these sorts of field guides are kind of broad blobs where we think they might be, often based on historical records. This gives very, very fine detail. On these maps we can get down to about 3 kilometres by 3 kilometres, which is more detail than has ever been possible before. Again, because there are so many people involved in this sort of project. And people analyse this data in all sorts of ways to figure out where to find a bird, where to protect a bird, and so on. Could we have the next slide, please? We can also not just figure out where a bird is now, we can also start to map out where birds move. In the case of birds, often when they are threatened, it's not just because they're threatened in their breeding grounds or something like that. Often they are suffering either on their migratory route or on their non-breeding grounds. This sort of information also allows you for a bird, like the dollar bird, to figure out where it's breeding, where it's migrating to, and so on. If we press the slide again, this will give you an illustration of how this bird moves through the year, from its breeding grounds to its wintering grounds and back again. Again, this is the first time that we've been able to, as ornithologists, map this sort of migration at fine scale, but on a global extent. I'll go on to the next slide. This is an example that will be familiar to a lot of you that are bird watchers. This is a global map of barn swallows moving between their breeding grounds and their wintering grounds and back again. So this is a bird that goes across the Americas, the African continent, Europe, and Asia. So this is again one of the first examples where it's possible for people to map the movement of a bird across its whole range. And that emphasizes to us that if you're trying to protect or understand a bird like the barn swallow, just looking at it in one region has limited interest, if you like, limited power, because this bird is moving around the world to such an extent. It's also important to recognize that using this sort of citizen science approach is not a silver bullet for everything. You can imagine that when you've got millions of bird watchers around the world contributing 1.5 billion data points, that data is quite messy. It's not like a classical experiment where you have 3 treatment groups or something like that. What that means is that you have to do, because you're not controlling so much how people enter the data, you have to do a lot of control, a lot of statistical control when you're trying to figure out what that data means. And on the right-hand side of this diagram, I've illustrated it, or I've noted a few of the things that we do to be able to try and control that data. So for example, when observations come into this sort of system, all around the world there are reviewers who are looking at whether this looks like a likely record, whether there's something wrong, and so on. So there's an expert review system in each country trying to figure out, does this look sensible? If there's something odd about the record, that reviewer will get in touch with the bird watcher and try and politely say to them, are you sure that you saw this bird in this area? And you can imagine that can be a tense conversation, but that's the first way of trying to ensure that it's good data. After that, most of this data is based on complete lists, so we ask people to tell us everything that they've seen, not just the most exciting things. That tells us when there are things there and when things aren't there, absences. And then you can see that we use statistics to control for a whole set of differences between species, between places, and between bird watchers. Controlling for differences between bird watchers is one of the hardest things. So we ask bird watchers to let us know how long they've been bird watching, who they've been bird watching with, where they've walked and so on. But we also have to figure out how skilled are they at bird watching, where they are right now. So we do a lot of statistical work to try and get this data as clean, if you like, as possible. We also tend to calibrate this messy citizen science data with real atlases and surveys and things like that, so that we know that what we're getting from these kind of big statistical analyses makes sense in the real world. So there's a lot of work that goes behind these sorts of models. And again, that work is being done by a huge distributed network of scientists. Can I have the next slide, please? Recently, we've also been trying to figure out not just where birds are now and how they move around, we've also been trying to figure out how populations have changed over time. That's pretty tricky. And it's pretty tricky because of that messiness of the data. Typically, when you're trying to look at differences in population trend over time, the main thing that you're looking at is how the numbers of birds have gone up and down, and so on. In this case, because it's real bird watchers around the world collecting this data, you've always got to be aware that, it might not be just the birds that are changing over a 20-year period, it's also the bird watchers that are changing. They've got better binoculars, they know where to go to get to see the best species, and so on. So you have to simultaneously control for changes in birds and for changes in bird watchers. We've now got some methods that different groups are figuring out how to do that, and it's producing maps like the one that you can see here. This is of the eastern part of North America. So you can see the Great Lakes there at the top, New York and so on across on the right. This is for a species called the wood thrush. If you live in this region of the world, this is one of the first birds that you hear in the spring singing from the woodlands. And each of these little dots here tells you what's happening in a small location in North America. Each one of those dots is about 27 kilometers by 27 kilometers. So a relatively fine scale. Normally you're doing population trends on a much broader scale than that. If it's a blue dot, it means that the population is doing well, it's increasing. And if it's a red dot, it means the population is declining. The size of the dot, be it either blue or red, tells you the extent of that change, whether it's a big change or a small change in that direction. And what you see here for the wood thrush is quite typical of what we find when we do this across different species around the world. What you typically find is that for many species, they're not just increasing or decreasing. You get this complicated spatial pattern where in some areas they're increasing and in some areas they're decreasing. So that's complicated biologically, but I think potentially hopeful with respect to conservation. Because even some species that we typically think are declining across their range, when you look at it very broadly, you often find there are some pockets where the population is actually increasing. And what we found people often do is they go to those areas and try and figure out, why is this endangered species doing well in these areas where it's actually thriving? So these maps are a new way into understanding how bird populations are changing, and probably also to try and figure out what we can do to bend the curve to make them increase again. Let's have a look at another couple of these maps to see how they work. Can we have the next slide, please? This is the familiar example, I suspect, to everybody in this audience. This is an Indian peafowl. See the Indian continent there? And you can see that most of the dots there are blue. That means that, as you have probably all noticed, the Indian peafowl is increasing across lots of India, becoming more common in general, and expanding into some areas where it was not seen so much. Even in the Indian peafowl, though, that is doing so well, you can see some red dots up in the northwest there. So this is the sort of example where people try to understand why might those red dots be there. You'll also see that not the whole of India is coloured in by a blue or a red dot. Some of it is grey. Typically what that means is there's either no significant change on the population, or it can't be detected with the data that's available now. Sometimes there are data gaps and you can't do that. So even with the peafowls generally doing well, just as the state of India's birds demonstrates. Let's have a look at another species. This is the Indian roller, another iconic species for India. When we all come out of the airport, the first Indian roller that we see, we stop the car, jump out and get very excited. Incredibly beautiful, charismatic bird. Again, when you look at that map, I suspect that you're already being able to interpret these maps. You can see that the Indian roller is, just as State of India's Birds Report says, is declining across quite a lot of its range at quite a large extent. But there are some areas, again towards the northwest, that are different from that, and it looks like there are some subtle increases in the population there. If you just pop back a slide, just go back onto that Indian roller. I can't overstate how useful it has been to be able to draw those maps with dots on them. They look pretty simple, don't they? I mean, there's a heck of a lot of bird watching and statistical analysis to get to those maps. But the fact that they look so simple is actually what's made them so powerful. When we show these sorts of maps to decision makers and people that we want to be interested in birds and conservation, they really get these maps quickly. The fact that they are just kind of a couple of colours, so they can see when populations are going up or down, they can see some spatial differences across there, and so they can see where they are. If they're a governor or something like that, they can figure out what's going on in my town versus across the rest of the country or the continent. So we have found these maps really powerful for communicating biodiversity problems to people and also helping them to take action. I'm just going to go through a few examples now of where people have taken action of that sort. Have a look at the next slide. The sorts of analyses that we've been talking about, for example, are now used in lots of parts of the world to identify the most important sites for protection. So this, for example, the map on the right there, is an example of where a whole set of groups came together, analysed this type of data, and identified 41 priority sites for shorebird conservation. The way they did that was pretty cool. They didn't just use the overall maps that we've been looking at. We have a tool that allows you to draw a little polygon around particular areas. So they drew polygons around different areas and calculated exactly how many shorebirds were present in each bay or in each beach or in each kind of tundra area and figured out for each week of the year which site is most important. Because for some of these shorebirds, they go through like real migration bottlenecks, where for most of the year you may not see any sandling, for example, in that area. But for 1 week of the year, 40% of the species can be in a short area of coastline. Using this technique, these groups were able to demonstrate that that has to be protected if we want to successfully keep hold of those species. Have a look at the next slide, please. Similarly, groups like Nespresso or Nestle have got lots of coffee farms across the Americas. They're very variable in how many birds they have associated with them. When you go to these coffee farms or fincas, like the ones in India, you'll notice that some of them have hardly a bird there at all. Some of them are actually pretty rich with respect to how many birds they have. Usually they're shade grown, they've got some trees above the coffee, but there are other things that farms can do to increase the number of birds. Nespresso and this collective of organisations this asked us, is there a way that we can figure out which farms are good for birds, why they're good, and then spread that good practice? So what the groups here did was that they used the eBird data to map all of the birds in Costa Rica. That's the blue map on the left there. They then calculated, they took into account how rich the different areas were, and then they calculated that each finca, each coffee farm in Costa Rica, they gave it a completeness, kind of a species completeness scale going from red to green. Where it's red, they don't have very many of the species you'd expect. Green, they have lots of the species you'd expect. So kind of greener fincas that are working really well with respect to biodiversity. And you can see how much diversity there is across even the Costa Rican fincas here. This information was then used by Nespresso and other coffee growers to spread good practice amongst their farmers and lift the level of biodiversity overall. So the impression that we get each time is, if we just tell these organizations that, you know, you're coffee farmers and you're terrible and you should stop growing coffee, that doesn't go anywhere. You know, we know that we have to, nature has to live alongside humans. But if we go to these organizations and say, here's some really good data that will help you actually not just grow actually better coffee, but also protect birds and talk to your customers about that, they leap on that information. The conflict disappears and they really want to use it. So this has been a very positive experience for us doing this. The other thing to note is that now the citizen scientists, the bird watchers of this area, have surveyed 30,000 coffee farms in Costa Rica and Colombia. Can you imagine how challenging that would be to do using kind of traditional routes, how many people and how much it would cost? These are the people looking at these coffee farms and giving that information to the corporate organizations. Let's have a look at another example of where people are using this sort of data. This one comes from North America. This is something that's a pretty hot topic in North America at the moment. You can see that the current, you probably heard that the current administration there really wants to have a shift to more sustainable sources of energy. And wind energy is one of the big sources that North America wants to use. If you look on those maps though, if you think about that kind of central track of North America going from kind of Montana through to Texas, there's a huge part of North America that has very strong and consistent winds, a huge amount of potential energy there. There's a great desire, therefore, to be able to put these types of wind turbines all the way through the east side of the Rockies. There are some other areas as well, but the east side of the Rockies is the one that people really want to invest in. Now we know that these large turbines, if designed in the wrong way and operated in the wrong way, and particularly put in the wrong place, can be dangerous for birds. These things can kill a lot of birds. We also know that if you avoid those things, you put them in more sensible places, operate them sensibly, and design them in a way to minimize the effect on birds, you can really reduce that risk. And I guess as a scientist, I kind of feel that part of our job is not to try to stop the wind energy industry or increase it, or anything. It's to give good decision-making data to these sorts of companies. So that's what we've tried to do in North America using eBird data. We used the fact that a couple of eagle species in North America are highly protected. and therefore these wind energy companies have to be very careful about any collisions with either bald or golden eagles. We then drew a map, the top right-hand corner there, of where those eagles are in North America. Again, completely based on citizen scientists. It's a very, very detailed map. And then we kind of did the inverse version of that map and said, well, if that's where eagles are, where are eagles not, if you like? And that's the green map at the bottom. This gives you areas where there are relatively few eagles. Again, remember with the Nespresso example, I said that once we created data that people could use, people really started using it. And once we started creating these maps, that this is where it's relatively safe to put an eagle, then the big federal agency in North America that is in charge of deciding who can put wind turbines where, started using that citizen science data for the basis of its decisions, which is a pretty big deal, because this is now a big, contentious, expensive industry in North America. The fact that they're actually using citizen science data to regulate that, to implement policy, is a very big deal. And of course, to do that, they had to really look at, who's collecting this data? How do you know the data is good? How do you know the analyses are good? But in the end, they were satisfied by that chain, and this is now part of the federal regulation in the US. Okay, next slide, please. So I've described there what I would say is kind of one of the great revolutions in the combination between technology and citizen science. And that's bird watchers going out, armed, if you like, typically with a mobile phone, collecting information, acting as sensors for the information that is out there, and using their mobile phone to put it into a system that anybody can use. A real blend of bird, real people using technology to do an amazing thing. There's a new revolution that's coming there. People observing birds is not the only sensor system we have anymore. Some of the same technologies that allow us to do fancy analyses of bird distributions and so on are also allowing us to automatically recognize which birds are calling and do it with a lot of accuracy. There are two areas for this that I think are going to be important, and both of them I would say are just kind of breaking now. These are things that, whereas the observational stuff we've been doing for 20 years, people really understand that around the world, this is the new thing that is happening. So we're using these automatic detectors of birds both on apps and in these little units, the kind of large white box on the front of that tree, autonomous recording units. These are boxes that you put out in the forest or the bush or the mountains, and it automatically detects the birds that are there. Let's have a look at the next slide. At the moment, most people are probably aware of these sorts of technologies through apps like Merlin. This is an app that comes out of the Cornell lab, but again is powered by people around the world providing recordings and text and so on. If you haven't used Merlin yet, I suggest that you have a go with it. In India, there is still some work to be done because there are so many birds here. It still needs more recordings to make it kind of a really fantastic thing. But the idea of it is you download it, you take out the phone, you hold it up when the birds are singing with no microphone or anything, and it can automatically detect, oh, that's a barbet singing, or that's a coral calling, or something like that. Now, the idea of that is not only that it allows you to know what bird that might be if you're a good bird watcher, it's also a great way for bringing people into bird watching, because it gives them confidence that I'd always wondered what that piping sound is. It's a barbet every morning. Once they learn that, then they learn the next species, and so on. So this has been where this is working well and gives people a really good experience, it has been a real breakthrough. The numbers of people getting involved in bird watching and passing that on to other people. Next slide, please. I won't go into great detail about how we do this, but roughly speaking, the way that you treat a machine to learn what a bird sounds like is by drawing the sound not literally on a piece of paper, but you effectively draw a graph of what the sound looks like. So you see that graph at the background there. Along the bottom, that's time, and on the vertical axis, that's frequency. So low down there is a kind of deep sound like this, and at the top, with a 10, it would be a high sound like this. So that's the frequency, and then time goes along the bottom. What we do is people go out, record bird noises, put those back into a central system, then bird experts look at these systems, and they literally draw a little box around each one saying, okay, that's a species of pigeon, this is a species of warbler, and so on. Now, by doing that millions of times, literally, that eventually tells the computer learns that, okay, that's what a pigeon sound looks like, that's what a cuckoo sound looks like, and so on. It requires an enormous number of sounds, and it requires an enormous number of experts to do that. But that's an area where birds are unusual. Both of those things exist with birds. As well as observing birds for years, people have been recording them and learning what their sounds call like. So groups around the world have been doing this repeatedly for the last 5 or 6 years to gradually build up a system where we now have machine learning algorithms for lots of birds around the world. Next slide, please. Excuse me. Here's an illustration of roughly how many species your phone can currently recognize around the world. In North America, that's a pretty good total, 540 species. Europe, 280 species, there are less species there. Central and South America, a really huge challenge there, but so far it can recognize about 600 species. And in India, it can do about 239. Now the objective of this, I would say right now, is not to try to get every species working in something like this Merlin app. The objective is to try to get enough of them working that when people use it, it's a satisfying experience and it can help with a lot of identification. I think it will take a very long time until we have something like this for every individual species. But I'll give you an illustration in a moment of how electrifying this can be for a bird watching community when it becomes useful. Let's have a look at the next slide. Okay, so in a moment we're going to play a few videos from people who are talking about this app. Now the reason I do this is really just to give you an idea of when you put that type of technology into somebody's hand, how excited they get about that. The videos we're going to show in a moment, nothing of them are anything to do with Bird Count India or the Cornell Lab of Ornithology or any of the groups around the world. These are just, I think, well, you'll judge the people yourself. But these are the closest we can see to normal people just talking, producing these videos out there just from their own enthusiasm. Now, they're a pretty mixed kind of group of people. They're talking all sorts of kind of excited ways. Again, what I want you to hear is the enthusiasm of that this type of technology generates amongst this bunch of people. Let's see if the video runs.
So I'm going to show you how to bird like a pro. And all you need is one app. That app is called Merlin. It's called Merlin Bird ID. The Merlin Bird ID app. Merlin Bird ID. Merlin. You just open this app and you hit Sound ID. You download like whatever region you live in. And then it'll identify all the birds around you and light up when they say, look at it. That was just all in like 5 minutes of me sitting out in my back deck.
This app is now part of my personality. I just left a work meeting, heard birds chirping, hopped in the whip, pulled the app out. House finch.
I'm obsessed. I'm never gonna stop using this app. Like, I can't even handle it.
So I'm addicted to this. Not in the literal medical sense, but I don't think I could live without it.
I'm addicted to this. So addicted. I'm addicted to this.
And that's like the sound app for birds. And you press play and it listens for the birds around you and it tells you what bird it is and what the bird looks like. So now my ass over here, since I've been using it, thinks I'm like a bird expert.
Okay, so yes, I've heard of the Merlin app before. I use it all the time in my backyard. Lots of birds we have caught on it. We got a yellow-throated warbler, I think it was called. We get blue jays, cardinals, white-throated sparrow all the time. And yeah, it's awesome app.
Here's the bird chirping. What kind of bird is that? My boo identifies it because she got the Merlin app. Is that a black and white warbler? No. Think it innocent. It's a Carolina blend.
Okay, that's enough of that. Now, I'll be honest, the way that we discovered this is not through, it wasn't some sort of planned thing. We went into the lab one morning and we suddenly found that loads of people had been downloading this app overnight. And we looked around and said, hey, who's done something really clever overnight? Has somebody been advertising it or someone been on TV? Nothing. We all said, we've done nothing. What's going on? It's crazy. I think there were about 60,000 downloads in a couple of hours one morning. It turned out, I don't know whether you noticed, but one of those people doing a video, she actually starts up in the morning, she's lying on a kind of couch on her deck or something, and she has a phone above her and she says, when you wake up in the morning, don't bother with Twitter or Facebook or something. She says, they'll just annoy you. Just turn on this app and enjoy birds and connect with nature. Totally, she's an influencer type person. You know, she's not anybody to do with birds. She did that in the morning. Millions of people watched. And she's an amusing person, I have to say. I've watched lots of her videos now, usually about the dog and the kids, but she's very entertaining. Anyway, millions of people watched that in the next couple of hours, and 60,000 of them downloaded Merlin. So when you get this sort of thing happening, it's a real kind of infectious way it goes through the population in a good way. Let's do the next slide. The other thing is that you could tell all of those videos were from people living in North America, I suspect, but other communities around the world are now using these sorts of apps as the first thing that they use to enthuse community groups, and particularly school groups and things like that. These are some photos from BirdLife Zimbabwe, who are having a big push at the moment to get people interested in bird watching. And you can see from the poster that they've got on the top left here, these apps are a big part of that. And what they're saying systematically in these cases is that this is the first time they've had something free that you can tell a whole school which species they're going to see in their schoolyard, which species they might see in the park, and so on. So in this case, sound ID isn't going to work very well in Zimbabwe. We just don't have enough recordings yet. But the fact that you've got a free app that people can look at and figure out what's going to be around has been a breakthrough for these sort of groups like BirdLife Zimbabwe. Okay, next slide, please. So those are the apps. People are now using these more and more to try to enthuse people and to connect them with nature and identify species. But do you remember I also mentioned there's a thing called kind of these autonomous recorders that people put out there, these little white boxes. Here's an example of this from the Western Ghats. The little picture in the top left there is a type of recorder called an audio moth. There you go, good zooming in. And if we go down a little bit to the map, this map will show you through the Nilgiris region about 50 recorders that were put through that region along a gradient of different types of forests. Some forests that were undisturbed, some forests that have been artificially regenerated, if you like, and some that have come back naturally after they've been logged at some previous time. The point about this is a pretty difficult region to survey and some pretty difficult species to survey. So here, they're using the same sort of automatic machine learning techniques, put the box out, let it run overnight, let it run for a couple of months, bring that back to the lab, and then analyze which species it's detected. Let's have a look at the next slide. These were the results with respect to the number of specialist species, of rainforest specialist species found in different sorts of forests. So you can see type of forest, undisturbed forests, those that had been restored and those that had been naturally regenerated. They looked at how common it was to detect a rainforest specialist species, and you can see, not surprisingly, in undisturbed habitats, nearly guaranteed to detect a rainforest specialist species, where in these other areas there was a significant difference of whether you're going to detect them. But the point about all of that is that this is a kind of automated way of detecting which species are in which forests and figuring out the effects of different sorts of management patterns. Here they didn't find a big difference between actively restored areas and naturally regenerated areas. But that's been really useful for the people in this case to figure out, okay, natural regeneration is an acceptable way of doing this. The challenge now is to be able to deploy this across a sufficient scale to be able to inform even bigger conservation decisions, and to know about enough species to have those machine learning algorithms for enough species to be able to actually get a representative slice of biodiversity. It's not just birds that you can use these things for, though. Let's have a look at the next slide. This slide shows you what we often refer to as soundscape. So this, remember I showed you before, we were talking about the graphs that have time along the bottom, from the beginning, the midnight to the next midnight in this case, and then you've got the frequency of call on the vertical axis. How red the box is on these sorts of graphs shows you how much acoustic sound, how much sound there is. So deep red sound means that you've got lots of sound going on. Pale red or no red at all says that there's no sound going on. This graph here, you can see it's night, then day, then night, and then you've got lower frequencies and higher frequencies. This is a pretty typical pattern. Often what you get is during the day at lower frequencies, you've got bird activity, so that red is caused by bird song, and you can particularly see the dawn chorus there. You can see that though at a higher frequency from the birds, you get a lot of insect activities, cicadas and grasshoppers and other insects that call. So often when you look at this graph, you can get an idea of not exactly which insects or which birds that are there, but how much there is. Now that's the pattern when you look at an undisturbed forest. Lots of birds and lots of insects. Let's look at the three different forest groups that were in the last slide. Next slide, please. The undisturbed one on the left, where you can see lots of birds and lots of insects. Look at what's happening in the other two boxes. Not only are there less birds in those two boxes, which we would have guessed because there are less, we saw less birds previously, hardly any sound at the moment from insects. So there's the potential link here. Well, firstly, there's the ability not just to detect birds, but also to detect insects and so on. There's the potential link also between drops in insects and drops in birds. One of the first kind of indicators that this type of thing might be going on. Okay, let's go to the next slide. This is also being used in wildlife management cases. So for example, we're using it to conserve the southern spotted owl by removing barred owls. Next slide, please. Looking at it to monitor fires across the Sierra Nevada in California. Next slide, please. And we're also doing major sound challenges to try to find new species and get the recordings from them, so we can do it in places like South America. Next slide, please. And in the next few weeks, we'll also be doing it to try to find more sound algorithms to recognize the species in the Western Ghats. The list of organizations over on the right, they give you the idea that this is now becoming a hot topic for all sorts of companies. Companies are interested in figuring out how to measure biodiversity and to show that AI can actually do things that are good for society. Next slide, please. So, hopefully you've got this idea that these two things, when they come together, the technology and the citizen science, I see them as potentially very exciting for taking us into new areas of biodiversity and trying to figure out, if we do the next slide, trying to figure out how we can bend this curve. Give us sufficient information to figure out which approaches work, which approaches don't work, which species are vulnerable, which areas are most likely to be protected. I'd say it's the first time that we've had that amount of useful data available to us, and it's almost all coming through a combination of technology and citizen scientists. Okay, thank you very much. I've really enjoyed being here. Thank you for listening.
Thank you so much, Ian, and thank you all. We have about 5 or 10 minutes time for questions. Please do put your hand up, and there's some mics that we passed around. And what we'll probably do is take 2 or 3 questions or comments together, and then ask them to respond, and then we can take the next step. So would somebody like to make a comment or ask a question? Yes.
Thank you. Thanks to the organization and welcome Ian. One question is the eBird checklist. I always have this doubt, statistically, without getting into details. If I keep reporting the same birds in my neighborhood, how is the count taken care of, duplication removed in the overall build-up of the data?
Good question. I mean, that's, I think, one of the things that people first think about. If I see the same crow every morning, and I report it every morning, are we going to think there's 10 billion crows in the South Bangalore? So when we're doing those sorts of maps of abundance and so on, we're not typically trying to estimate the absolute number of crows that are there, or the absolute number of, the exact number of species, but not the exact number of individuals. Those estimates are usually the likelihood of somebody seeing a crow if they watch for 10 minutes. So it's a relative likelihood of seeing the crow. So the fact that you actually record that crow every morning is perfect for eBird, because that gives us a good idea that if somebody is living there, crows are very detectable and we'll see them every morning. The disadvantage is we don't get to absolute density. Getting to absolute densities for this sort of data is really challenging. It's almost all relative information. Does that make sense? So keep recording the crows, that's great.
Thank you.
Yes. Good evening, Professor Ian. Wonderful talk, thank you. And I don't know if this question is within the scope of your lecture today, but my question is, where do we draw the line in conservation? Are we supposed to let the birds take a natural course of evolution and let them adapt to the current conditions that the world is going through, or do we restructure forests and landscapes to suit the birds that we had before?
Excuse me. So the question is, in conservation, do we let the birds take the natural course? Some of them will go extinct, some of them may adapt, or do we try to conserve the forests and so on to protect some of those bird species? It's a good question, because I don't think we should just blindly try to protect everything. That's probably impossible. Oh, thanks. It's also true that extinction is a natural process. It takes place all the time. The difference right now, I would say, is that extinction is occurring at a rate much, much, much quicker than it ever has done before, even during those great extinctions that have happened on the Earth a number of times. Estimates vary between areas and between groups and so on, but extinction is probably currently occurring at about 10 to 100 times more rapidly than it's ever occurred before. In that situation, I think it's important that we step in and try to manage that problem. If we don't do it, I suspect that birds are just an indicator of what's happening in many other groups. My guess is that those early indications of the insects not being in some of those regenerated forests, my guess is that's very important. And in some of these forests and grasslands, the insects are really declining. That's hard to show, and the birds are an indicator of that. So my guess is that if we let things collapse at 10 to 100 times the rate than before, life wouldn't go extinct on the planet, but it would lead to a huge impact on natural systems, and I suspect on our culture and systems as well. And we're not that far away from that. So I think we should intervene in a careful way. Also, if you look at the rate of evolutionary adaptation, creatures can adapt pretty quickly. But there's some evidence now that even though creatures have been able to adapt over the last 20 or 30 years, there's an erosion in genetic variation to be able to let them do that for another 100 years. So I suspect we've been using up a lot of the genetic variation that's there, and we won't be able to draw on it. We'll be dependent on new mutations to adapt further. So it's in a delicate patch right now to just let it go. I think that will be disastrous.
Thank you for that talk, Professor Owen. During COVID, the 2 years that a lot of us, had to stay indoors, we found in the urban areas of our city a lot of exotic species were seen. Just outside our window, we saw the Asian paradise flycatcher, and that was amazing. So, was that? I mean, we don't find him coming back anymore. So, for 2 years, is that because of COVID and because of, you know, the lack of too many vehicles and people going out? Is that what made the birds come in?
I think I would guess it's a combination of things. COVID was a remarkable period for all of us, wasn't it? If you were an ornithologist and you were involved in one of these organisations getting people involved in nature, actually there was a huge boost in the number of people that started looking at nature around them and making careful observations, just as the type that people really became interested in local nature. And I think it became relevant for them. A lot of the organisations that we all work for are still benefiting from that. Those people haven't gone away. They are still interested in our organisations, they are still bird watching and so on. In cases like that, I think you're right that the analyses that have been done with these sorts of data, several of them have shown that, yeah, nature came back into the cities more, but also we were watching out for it more. And you've heard me refer a few times to, you've always got to be careful of what the birds are doing and what the bird watchers are doing. There was a lot of data coming in during those, particularly those pandemic lockdown periods. So we tended to know if there was a paradise flycatcher out there, as well as it actually being there. But yeah, I would say that COVID inspired a lot of people to become more interested in nature. So it was a heavy price to pay, but it's been interesting in that respect.
Yeah. I'm just curious if eBird here. eBird data is being used along with other data sets, like, I don't know, even temperatures, plant, whatever, any other big data sets, and like, is a combination being used by someone, or is there a plan to use that too?
That's a great question. So I've mostly spoken about eBird type data today, but how can it be combined with other databases? Yes, I think that's vitally important. I would say that we've spent a decade or so kind of getting these systems working, inspiring citizen science networks. Now, a lot of us are thinking about how you combine it with other types of biological data and how you link it with physical factors as well. You know, sometimes it's possible to think, well, maybe we should stop. You know, people have typically done this type of work using structured surveys once a year or something. And it's tempting to think, well, maybe we don't need to do that anymore because you can just use this kind of eBird type of work. Actually, we are finding that it's when you combine those types of data, it's really powerful. The atlases and so on act as a calibration for the citizen science data. So I can't show you those analyses, but at the moment lots of us are scratching our heads and looking at these combinations and realise, like you do, okay, we've got to make this more possible.
Thanks. Super powerful talk, and I think at the intersection of technology and citizen science is just so powerful. How do you see AI, technologies like AI, really shaping conservation? I know that you use data sets from citizen science, but specifically in conservation, are you excited about the potential of AI? Are you using AI as a scientist in any other different ways? I saw the autonomous boxes, that's a great way. But AI is so powerful. In the last 1 year, there's so much that's happened in AI in the world. So are you using generative AI? Are you using other use cases to really shape conservation?
Okay, that's a highly topical question, isn't it? I almost feel bad saying this, but I am excited about AI. I am less fearful and more excited. Almost everything that we just spoke about there, be it sound recognition of bird songs, or complicated analyses of where birds are, and particularly that stuff where you've got kind of bird populations going up and down, they are now all dependent on machine learning models. We didn't talk about it today, but there's also a group that we work with which uses radar data on a kind of continental scale, strips out the aircraft, strips out the insects, and then just uses the data for where the birds are to show kind of continental flyways of where the birds are going. It can actually tell you that tomorrow night there's going to be a big migration of birds, totally based on machine learning. So I think that now that the world is gathering so much of this data, it's going to eventually be the kind of primary approach that we use. I think it's sensible that people are wary about it at the moment because you don't want to introduce effects we don't know about. But I think that's an important phase for us to figure out how we're going to use machine learning. Of course, a lot of the attention at the moment isn't around whether we're using AI for bird populations and so on. It's, as you say, it's the large language models and the generative stuff. I'm even excited about that because what we've just been talking about that here, I suspect many of you are at the university and so on, so you will all be skillful enough to use eBird type data and draw graphs and do maps. It's good for all of you because you've learned those skills. The rest of the population though just want to be able to ask a simple question. Tell me whether vultures are declining. Why are vultures declining? Tell me what's happening with that roller. They want to be able to ask that question in an everyday way. Now, if somebody asked us that question and Sir Hal and the rest of the team sit down for a week, they could give that answer, but it would be pulling data from lots of spots. We are really interested in using large language models to train on these sorts of data sets so you can produce the answers that people want in real time. We're trying to figure out the most effective, including cost-effective way of doing it. We're really interested in building a kind of conservation large language model on top of the models that already exist. Excuse me, if we can. I think that will be exciting. I would love school groups to be able to just go to a portal, type in their questions about wildlife, and get those sorts of answers with it. Because we've got so many photographs and graphs and audio recordings and so on. I think it will be inspiring. But we're going to have to use some technology to build that out.
Thank you. I think we can take one more question. We're getting to yes.
There's an experience about urban vegetation improvement and the linking with the bird biodiversity in the context of talking about bending the curve again backwards. I feel over the experience there is a big gap. Suppose some urban vegetation species are suggested. It takes more than 15 or 20 years to really change which species to be grown.
Mm-hmm.
So do you have any experiences where this can be done faster? Because the pressure put by conservationists may not be speedy enough or impactful enough. And suppose they link it politically every 5 years there will be a change of the governments. Whether a particular government stays or changes, how to make the conservation strategies, go in a particular standard way so that whatever the government changes, at least the conservation efforts are not affected very seriously.
Yeah.
Can you have any comments on this, or you have experienced such a thing where this can be done faster, say putting pressure to the UN at the international level using this data?
Okay, that's a good set of questions. The question, I guess, boils down into a way that, are there examples where people are using this sort of data to speed up the rate at which you can observe things, and sometimes using that to inspire federal and even international governments to take action? There's limited information on that, I would say. I would say that one of the reasons to try to get this sort of data together is to do the sorts of things that you're talking about, compare different approaches and be able to say, this one works really well, this one works much less well. If I was to try to pick local examples of how that's done, when we were in Nilgris, for example, we were visiting the Nature Conservation Foundation, which has got a network of regenerative patches across that upland environment and amongst the tea plantations. Now they had extremely detailed information. I think they had about 70 patches they were monitoring, and they had extremely detailed information on which ones were coming back fastest and which ones were attracting rainforest species into them and so on. And they were doing that surveying using citizen science data of different sorts, including, as it happens, eBird. So I think that's the sort of thing I would point to, where using this sort of information, they are really within, in those cases they had about 20 years data, They were really now being able to inform, this is what works in those sorts of situations. As for informing national or international governments, I agree that we all know that it's, one has to be careful just waiting for a national government or international governments to do things. So personally, I'm of the persuasion that one needs to work at different levels. Sure, we need to be able to pull these things together. I personally think that we need to do it at an international scale and say, look, here are 500 bird species that we understand well. This is what's happening to them. And we do take that to the equivalent of the United Nations. I also think it's really important to work locally as well. Because if one is always waiting for somebody else to do it, there are going to be periods when that doesn't work well. So I think it's important that we don't just work with national governments, we work with local organizations, corporations, and states and local governments, because often that's where you can get work to happen quickly. When the two things come together, that's wonderful, of course, but by working with a broader set of stakeholders, you can keep the ball rolling. It's better.
Thank you. I think we could go on discussing, but I think that the questions we've received so far have been really thoughtful and challenging. Thank you again for addressing them. So we draw this to a close. I think there's one more item of business, but thank you very much, Ian, and
thank you, everybody.
Thank you all.
Thank you, sir. I now invite Abhishek from first year NSA to give away the vote of thanks.
Good evening, ladies and gentlemen. As event comes to the close, I deem it a great honor to propose vote of thanks to all who have helped making this event such a resounding success. On behalf of St. Joseph's University, School of Life Sciences, Department of Zoology, I thank Professor Ian Owens for sharing valuable time and experience in the field with us. It was both enlightening and inspiring. I firmly believe that this talk will serve as a guiding light and will drive some of us to study and explore this fascinating world of birds. My heartfelt gratitude goes to the collaborators, Big Bird Count, National Center of Biological Science, NCBS, Nature Conservation Foundation, NCF, who joined to make this event reality. I would like to express my profound gratitude to the Vice Chancellor, Pro-Chancellor, Registrar, Dean of Life Sciences, St. Joseph's University for supporting and encouraging activities such as this. The successful culmination of this public lecture owes much to the guidance and support of our head Department of Zoology, Dr. M. Jayashankar, and Association Teacher Coordinators, Dr. Sarjan and Dr. Magesh. And the entire Zoology Department, thank you so much for making the event a success. In order for this event to run smoothly and beginning to the end, the continued cooperation of student coordinators and volunteers alike is very much needed. A huge shout out to all of them for efforts. Their efforts were indeed fruitful. Lastly, but certainly not the least, I thank everybody who are present here. Your participation indeed much appreciated. Once again, I'm thankful for all of you, your cordial cooperation. See you again for another event in St. Joseph's University. Happy weekend. Thank you.